Welcome back. Are you here? The question is, we have a function f of x equals to x cubed minus 6x. You are asked to use the right endpoints where a is 0, b is 3, n is equal to 6. Find the Riemann sum and find the integral. So we know that summation I from 1 to n f of xi delta x. This guy is the Riemann sum, and integral a to b f of x dx equals to limit n approaching infinity summation I from 1 to n f of x I delta x. So this is the equivalence for the integral. So if you find the sum of the all the rectangles of a sum of the areas of all the approximating rectangles, then that is, you already know, is known as the Riemann sum. And if you apply the limit n approaching infinity on this guy, and you do not take the finitely many intervals, you take the n intervals and apply the limit, then you can say yes, this is the equivalent answer for this, which is for the integral. So one thing you should make sure, maybe I didn't clear enough in the previous part, that this guy is Riemann sum, and when you apply the limit n approaching infinity, then it is equivalent to integral. So if separately I'm asking you to find the Riemann sum, you need to find the sum using this data. And if I'm asking you to find the integral but not using the integral formula, then you will use the same Riemann sum to give the answer of the integral. So here, first part is find the Riemann sum. For the Riemann sum, I need three things. I need delta x. I need the determination of which points should I use, the left points, mid points, or the right points. So here he has told you that use the right endpoints. So I know that I have to use this right endpoints. Then I can find the delta x, and using the delta x I can evaluate this sum. Now given n equals to 6, you already know this thing, you have solved it. Let us do it for this function again and see what will be the difference when you apply a limit on it. Now when n is equal to 6, so delta x is b minus a divided by n, that is b is 3, a is 0, so 3 minus 0 divided by 6, it is 1 by 2. It means for the interval 0 to 3, for the interval 0 to 3, you can split this whole interval with the gaps of 1 by 2, with the width of 1 by 2. So the intervals will be 0 to 0 0.5, then 0 0.5 to 1, then 1 to 1.5, 1.5 to 2 to 2.5, and 2.5 to 3. Now these are my intervals, and I am already given that I am supposed to find the sum using the right endpoint. So I am interested in these numbers. I can use them in the formula. The Riemann sum formula is summation I from 1 to n f of x I delta x, that is summation I from 1 to n is 6, 1 to 6, f of xi delta x, or you can write it as, if you open the sum, it will become f of x1 delta x plus f of x2 delta x plus so on, means f of x3, f of x4, f of x5, and the final one is f of x6 into delta x. Now what is f? You know the function f is this. So you can simply replace this f of x1 with this. But what is x1? x1 is the first endpoint, 0.5. So the value of f of x1 can be calculated. F of x1 means f, the value of the function at 0.5, means replace this x with 0.5. So it is 0.5 this cube minus 6 into 0.5. When you multiply them together, you will get a number. So this is f of x1, and you can put that number here, and if I have calculated, I can write it for you, but I didn't calculate. Anyways, that number will come here, and delta x you calculated here 1 by 2, so it is 1 by 2. It is fixed for all. Similarly, f of x2 means you need to put the second endpoint. You are using the right endpoints. This is the first endpoint, 1 is the second right endpoint, so f of 1. So in the function, replace x with 1 and then calculate. So it is 1 minus 6, the answer is minus 5. So you can put it here, it will be minus 5 into delta x, plus same with the f3, plus f4, plus f5, plus f of x6 into delta x. x6 is the final point, so here it will be f of 3. Replace the function with x with 3 and multiply them together, you will get a number, put it here into 1 by 2. Now when you simplify all this, you have done this in the homework, the answer is, I have done this on the pages, you can read them later. The purpose here is explanation and find what is the difference. 9375. So the answer of the Riemann sum for this data is minus 3.9375. The second part of the question is find the integral. Part B is find definite integral. And I know that the definite integral, the limiting points are a equals to 0, b equals to 3. These are given. So the definite integral will be 0 to 3 f of x dx. It is equal to the limit n approaching infinity of the Riemann sum. But you will not put this value here. But here the Riemann sum means you will not solve the expression for this data, but actually you will solve this expression for n, because you are using the limit n approaching infinity. You are not going to split the intervals into these smaller intervals. You will actually assume that your number of intervals are n. So I need the expression for the Riemann sum, and that is limit n approaching infinity summation I from 1 to n f of xi into delta x. So I need everything in the form of xi, which you have done already, you know this. Now I need what I need. I need f of xi and delta x. So first I need to calculate delta x for n. For calculating delta x, I have the formula b minus a divided by n. Now in this case, when you apply the limit, then you will not take any value of n. You will assume it n. When you do not apply the limit for the Riemann sum, in that case, you can divide this interval for the given strength of n. This n was given to you 6 in the first part. So in that case, you can get a definite answer like this. But when you are trying to apply the limit n, then you will ignore this n and assume it any n. So you are assuming that you don't know how many intervals you are splitting the big interval. It is infinitely many n's. So you are keeping it n, but these values you can replace. So it is 3 minus 0 divided by n, so it is 3 by n. So 3 by n is the value of delta x. Let us keep it noted here. So I have got the value of delta x 3 by n. Now I have got this thing. Now I need expression for xi. What will be the general ith expression for this function for this delta x? I know that x naught is the first point, 0. x1 is 0 plus delta x, and delta x is 3 by n, so it is 3 by n. x2 is 0 plus 2 delta x, means 2 times 3 by n. x3 will be 3 times 3 by n. So it means that xi will be I times 3 by n. Got it? You understand? So I have got both the things which I need for this formula. Now I can replace this formula with these values. So this expression will be limit n approaching infinity summation I from 1 to n f of xi. I calculated already. Xi was 3i divided by n, and the delta x was 3 by n. Okay. Now what does this mean? It means the function value at this number. So I will replace this function with this number and put it here. So instead of f of this, I can have this function and replace the x with this number. So it will become limit n approaching infinity summation I from 1 to n. This value put in place of x in the original function. So it will become 3i divided by n whole cube for this x minus this 6 into 3i divided by n for this x into this 3 divided by n. Now I have an expression in terms of n. What next? Next is, you have done this thing in homework. I have to simplify these guys to get an expression on which I can apply the limit. 81 by n4 into summation I cube, I from 1 to n, minus, similarly keep this guy outside, 54 by n square into summation I from 1 to n I. Is this okay up till here?
Yes.
Now I have written these two formulas already in the today's lecture. That is limit n approaching infinity 81 by n raised to the power 4 into that formula, and that formula was this is summation I cube. So for the I cube we have the formula n into n plus 1 divided by 2 whole square. So this sum will be replaced with this, minus 54 by n square into summation I means sum of first n integers, that it is n into n plus 1 divided by 2. Now we have got rid of the summation sign. So now multiply them together. Limit n approaching infinity. If you take this 2 outside and keep this n4 inside, just to combine them, so it will become 81. Oh, it will not be 2. It has a square on it, so it will become 4. So it will be 81 divided by 4, right? This whole thing has a square. So on the upper term we have a square, on the lower term we have a square. 2 raised to the power 2, 4. So I am taking 4 outside below 81, and inside I am keeping this n4 inside. So it will be n into n plus 1. The upper term has a square divided by this n4. Just a manipulation. Minus, let us apply the limit separately. So for this, again the limit n approaching infinity. Again same thing, keep this 2 outside, but here this time it is not a square. So it is just 54 divided by 2, and keep this n square inside, so it will become n into n plus 1 divided by n square. Now limit n approaching infinity 81 divided by 4, I don't know, let it be here, into, if you open this square, it is n square into n plus 1 square separately and divided by n4, minus limit n approaching infinity 54 divided by 2, it's 27, into, multiply them, it will become n square plus n divided by n square. Now here it is limit n approaching infinity 81 divided by 4. If you take n square common from here to outside, it will become n4, and inside it will be 1 plus 1 over n divided by n4. You can simply expand this square and then do the calculation. I just took common n, and when it comes outside it becomes n square because of this square. If you don't understand this step, you can simply open the square formula and then multiply, and it will become again the same. Anyways, minus limit n approaching infinity 27. Now if you split them, it is n square divided by n square 1 plus n divided by n square 1 over n. And here this cancels, so it is 1 plus 1 over n. Now we can apply the limit. Up till now, up till here, why we did not apply the limit here? Because if we apply the limit, this will become infinity by infinity. That is undeterminate form. We cannot do that. Now we can apply the limit, so it will become 81 divided by 4 into 1 plus 1 over infinity, that is 1, minus limit 27. When you apply the limit inside, it is 1. So do the calculation. The answer is what? Minus 6.75. This is the answer for integral from 0 to 3 f of x dx, which is equal to limit n approaching infinity Riemann sum I from 1 to n f of xi delta x. Now what is the difference? What happened actually? The problem here is that answer by using the limit n approaching infinity, summation I from 1 to n f of xi delta x, the answer is minus 6.75. And without applying the limit infinity and splitting the interval into larger number of dx, where I from 1 to 6 f of xi dx, which we have done when for keeping n equals to 6, and the answer was minus 3.9375. Both are the same things. Both are telling me that if you plot the function, this given function which is x cube minus 6x, it is like this. Now these two formulas both are giving me area for these regions. This is 3, this is 0. So this is the region which I am interested to find the area. This region and this region. This one and this one. From 0 to 3, I only want to know the area above the line or below the line, but under the curve. When you go below the line, the under the curve means the part which is above this curve, below this line. And when you go above the line, when you are above the line, under the curve means the part which is above the straight line but below the curve. So both these formulas are giving me the area, this region plus this region. But here the answer is minus 6.75. Here the answer is minus 3.93. Why? Zephyr.
Because of different delta x. Okay, and
because of
okay.
Yeah, you're right. Because of delta x. Here we took the delta x very large. In this case, what we took, we assumed delta x is 0.5. We took 1 by 2, right? So when we took delta x 1 by 2, it gave me this answer. When I said, okay, delta x is not 0.5, actually delta x is approaching 0. It is somewhere 0.000000, like this. The answer appeared like this, because when delta x approaches 0, it means n approaching infinity. Means we have divided the interval into infinitely many times. So if we divide the interval into infinitely many times, it means we are taking the width of the interval approximately equal to 0. So the smaller we have taken the delta x, the accurate is the result. The larger we have taken the delta x, the more fast is the. You can see how much difference is there. It's a big difference because of this guy. Both these formulas, when you apply the limit, it is the same. What is this guy? This is the same formula which is here. But in this case, we have considered that we are taking infinitely many subintervals. In this case, we said that we are only taking 6 subintervals. That is the difference. Now, if you do the same, and instead of 6, you take 12, then this answer will improve. Maybe it will become 4, minus 4 point something. And if you do this for, let me say, 50, this answer will certainly try to reach there. And they told us that when we take n equals to 40, means when you divide 3 minus 0 divided by 40, 3 divided by 40, when you take this delta x, 3 divided by 40, when you take the delta x equals to 3 divided by 40, then this expression will give you an answer somewhere around 6.72, something like this. So you can see delta x is drastically changing your accuracy and the efficiency of the result. Categorically, both are giving you the same thing, this and this. But in case of this, you are only taking this region from A to B, limit and approaching infinity. But in case of this, you are always dividing these regions into rectangles, and then you are calculating the areas of each rectangle, and then you are adding them together. This is the area 1, suppose, and this is the area 2. Then when you go below the line for a curve, when you go below the line, the total area is always the area here minus the area below. Both cases, the rule is same. The above area minus below area. Both cases, the rule is same. But in this case, you are always splitting this region into rectangles, and every time you are adding a margin of error into it. Now, the smaller you will split this, the more accurate will result this. And here in this case, you are splitting the region, but that is not, you are not able to determine the width of the rectangle. Again, you are splitting the region, but the region is splitted infinitely many times. So it is approximately looks, with the naked eye, it looks a whole region in between these two limits, 0 and 3. That is the difference when you calculate with the smaller delta x and larger delta x. Understand?
Yeah.
So, the summary of whole discussion today is I have written a lot of theory. You can read it if you want. If you don't want, then it's up to you. The summary is that the Riemann sum is equal to summation I from 1 to n, but this n is finite. You have n 6, 10, 40, 50, 100, but finite. F of xi delta x. So this is called the Riemann sum, the sum of the areas of the approximating rectangles under the curve. And the integral from a to b f of x dx, this is equal to limit n approaching infinity, the same guy, summation I from 1 to n, but this time n is approaching infinity. It is not finite. This time, this n is approaching infinity, f of xi delta x. Same formula, but this formula gives you the integral with more accuracy. This formula only gives you the sum of the areas of the smaller rectangles which you have splitted one by one. Both represent area under the curve, but this is more accurate as compared to this. Both can be equal if you increase this n. If you try to take very large n, for example, if you take n equals to 1000 and already your interval is very small, for example, if you are talking about 0 and 3, this is your interval, and you take n equals to 1000, means you divide this interval into 1000 subintervals, then for this interval, this value is something like infinity, because the interval is already very small and this is a much bigger value. So this n is already approaching infinity for this guy, because this is already very small. If you have an interval like 0 to 1000, now if you divide this interval into 1000 subintervals, what will be the delta x? The delta x will be 1, which is still a very big quantity for the delta x. So it is depending on how much is the interval initially. For this, even if you take n equals to 1000, still it is not an infinite. It is a very small number, because the whole interval is very big. But here the interval is very small, or even if it is 0, 1. Now for this guy, if you split this into 1000 subintervals, it will be a kind of infinity for it. N will be infinity, but for this guy, it is not an infinity, it is just a number 1. So you can always get more accurate result the number of times when you increase this n. If you are finding the value for 6, your result is some number, and now you increase it one number. You increase the number of intervals 7, the answer will improve. 10, answer will improve. It will keep on improving the number of with the number of n, or with the side of delta x. So in simple words, delta x is inversely proportional to n.